A magnetic field is created around this wire. The solenoid has 5 layers of windings. The 12 centimeter side is parallel and perpendicular to the field. So current flowing through the galvanometer is 10 milliamps. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. I have started discussing the problems on the chapter Moving Charges and Magnetism, where my primary focus was the concepts from magnetic field due to a circular coil, force acting on a charged particle in the magnetic field, force acting on a charged conductor in the magnetic field. Today, we will concentrate on concepts like solenoid, toroid, and conversion of galvanometer into an ammeter, voltmeter, etc. First problem. The problem says horizontal overhead power line. There is an horizontal overhead power line which is carrying a current of 50 ampere in the north-south direction. Horizontal overhead power line. A wire antartha, horizontal cable which carries a current of 50 ampere in the north to south direction. What is the magnitude and direction of the magnetic field due to the current 2.5 meter below the line? Which means I assume this is a horizontal cable, a horizontal power line, horizontal wire which carries a current of 50 ampere. Then what is the immediate consequence? The immediate consequence is a magnetic field is created around this wire. Yes, magnetic effect of electric current. There is a magnetic field created around the straight wire. We have to calculate the magnetic field at a distance 2.5 meter below the wire. Do I know any expression here? Yes, magnetic field due to a straight wire carrying conductor, which is mu naught by 4 pi 2I by R. You need to remember this expression. Magnetic field due to a straight wire carrying current, mu naught by 4 pi 2I divided by R. This is 10 power minus 7. Yesterday we saw mu naught is 4 pi into 10 power minus 7 divided by 4 pi. 4 pi and a 4 pi gets cancelled. So 10 power minus 7 into 2 into I is 50 divided by 2.5. So the answer turns out to be 4 into 10 power minus 6 Tesla. Direction of the field is also asked. Refer back to the session. This is an assignment. I give you the hint. It will be towards east. Use one of the laws. You will get the direction of the magnetic field. The next one, students. A closely wound solenoid 80 centimeters long. The solenoid is 80 centimeters long. Solenoid. Rheostat. Upayogistirtive labally. Has 5 layers of windings. The solenoid has 5 layers of windings of 400 turns each. So a closely wound solenoid which is 80 centimeter long. The length of the solenoid is 80 centimeter. It has 5 layers of windings, where each layer has 400 turns. The diameter of the solenoid is 1.8 centimeter. If the current carried is 4 ampere, estimate the magnitude of the magnetic field inside the solenoid near its center. Now, the length of the solenoid is given, which is 80 centimeter, or on conversion 0.8 meter. So length of the solenoid 80 centimeter or 0.8 meter. There are 5 layers of windings, and each layer has 400 turns. So capital N will be 5 into 400. which is 2000 turns. 5 ಲೇಯರ್ಗಳಿದೆ. ಪ್ರತಿಯೊಂದು ಲೇಯರ್ ಅಲ್ಲೂ 200 ಟರ್ನ್ಸ್ ಇದೆ. So total number of turns is 5 into 400, which is 2000. And number of turns per unit length, this is capital N by L is small n. Number of turns per unit length, which means small n is 2000 divided by 0.8, so 2500 turns. Now, what is the magnitude of the field inside the solenoid? If you remember the expression, B is mu naught N into I. This is at the center of the solenoid. If it is at one of the ends, this divided by 2. So on substitution, 4 pi into 10 power minus 7, small n 25 into 10 power 2, that is 2500. Current is 4. So this is equal to 1.25 into 10 power minus 2 Tesla. So the simplifications, take care, but I'm giving you with the substitutions and the calculations. The next problem, students. A 15 turn, so number of turns is 50, with sides 15 centimeters and 12 centimeters. So 15 centimeters and 12 centimeters is placed with its plane parallel to a uniform magnetic field. Parallel to a uniform magnetic field of strength 4 into 10 power minus 4 Weber per meter square. Magnetic field strength. For a current of 0.4 ampere in the coil, what is the torque when the 12 centimeter side is parallel and perpendicular to the field? So you have to calculate the torque when the 12 centimeter side is parallel and perpendicular to the field. In the first step, I will calculate the torque. Generally, the torque acting on the rectangular slab, where I know the torque B, B-I-N-A. So the torque acting on the rectangular material in the magnetic field, tau equals B-I-N-A, which is B is 4 into 10 power minus 4, I is 0.4. So 4 into 10 power minus 4 into 0.4 into 50. So area 0.15, 0.12. So on simplification, this is 1.44 into 10 power minus 4 Newton per meter. Now comes the interesting fact. This is generally the torque acting on the rectangular slab. But if you analyze the problem, you're asked to find the torque when 12 centimeter side is parallel and perpendicular to the field. Remember, students, in either of the case, torque has to remain the same. If the 12 centimeter side is either placed parallel or perpendicular to the field, the torque acting on it remains the same. The next one, and this is repeated questions in the exam, and if you can analyze, most of the times in the entrance exam, such type of problems are asked. A moving coil galvanometer has a resistance of 30 ohms. There is a moving coil galvanometer which has a resistance of 30 ohms and gives full scale deflection for 10 milliamps. So current flowing through the galvanometer is 10 milliamps. How do you convert it into an ammeter? Galvanometer has to be converted into an ammeter which can read maximum up to 10 ampere. So here is a problem, a numerical, where a galvanometer has to be converted into an ammeter. Theory nalvodidira. If you have gone through the sessions, it is very clear to convert a galvanometer into an ammeter. Low resistance has to be converted in parallel with it. What is that low resistance called? Shunt resistance. So in order to convert a galvanometer into an ammeter, a shunt resistance has to be connected in parallel with it. Now, resistance of the galvanometer is given G 30 ohms. Current for full scale deflection 10 milliamps minus 3 amps, and current, maximum current rate is 10 ampere. Now, what is the expression for shunt resistance to be connected in parallel? So, S equals Ig into G divided by I minus Ig. You have to keep these expressions in mind. The shunt resistance S equals Ig into G divided by I minus Ig, or S equals Ig minus 30, 10 minus. So on substitution, this is Ig into G divided by I minus Ig. So this is 0.03 ohms. So to convert the galvanometer as an ammeter here, a shunt resistance of 0.03 ohms has to be connected in parallel with it. And you will have to write this as a comment. The next one of the same type, again important. A moving coil galvanometer now has a resistance of 75 ohms and range 0.15 milliammeter. How do you convert it into an voltmeter? Up to 15 volt. Now the galvanometer has to be converted into voltmeter. How do you convert? Yes, by connecting high resistance in series with it. What is the expression for high resistance? So R is V by Ig minus G. You do this concept as an experiment also. Conversion of galvanometer into an voltmeter. So this is voltage is 15 volts. Ig is 0.15 milliamps into 10 power minus 3 minus 75. So on simplification, this turns out to be 925 ohms. So in this case, to convert galvanometer into voltmeter, high resistance of nearly 99,925 ohms has to be connected in series with it. So in my today's session, I have solved problems on the conversions part and the rest of the chapter. Preferably in the next session, we will work out a few problems from the NCERT textbook. Until then, have a nice time. Thank you.